Good morning, physics class. We're going to work on this paper that you had last week. We were down here looking at, we did some friction problems here. We started looking at this Susan problem, but we're going to actually flip it over. We'll work on the friction later. We're going to try a nonlinear dynamics problem. It's very similar to the problems we solved over here in problems 1A and 1B. The only difference is back here, the force applied is no longer horizontal. It has a vertical component. It's up and to the right or down to the right, something like that. So we've got a 65 kilogram refrigerator is dragged across a level floor. So be careful with level floor. It's not on a ramp. Later down below it'll be on a ramp. We're just doing level floor at a constant speed of 1.5 meters per second by a 310 Newton force applied at an angle of 30 degrees above horizontal. We're going to find the coefficient of kinetic friction. So we want to find the coefficient of kinetic friction. We know the acceleration is 0. We're going to end up using Newton's second law. So we're going to draw a free body diagram of this refrigerator. I'm trying to stay out of the way. Terrible refrigerator. It'll work. Okay, so we got a normal force up, level floor, right? If you want to draw the floor, you can draw the floor. Gravity pulls straight down. I'm going to have it moving to the right. So if it's moving to the right, friction's to the left. It's being dragged across the floor. We know it's going to move. It's already moving. So that's kinetic friction, F sub K. And then we're pulling, if it's pulling it across the floor, we must be pulling this way somewhat. And it says above horizontal, so we're going to draw the force applied up and to the right, like that. I'm going to throw a piece of paper under here just to make it easier for me to write on this table. Okay, so what are some knowns we've got? We've got a 65 kilogram refrigerator, so mass is 65 kilograms. Constant speed. I don't really care about that speed. I care about the acceleration being 0 meters per second squared by a 310 Newton force. That's the force applied. And I drew this at an angle of 30 degrees. If you want to, you could put that in there. I'm not going to force you, but 30 degrees there. Find the coefficient of kinetic friction. So mu sub k is our unknown. Right? We're going to use Newton's second law. I'm not going to make you write that. Let me know on the test if it says what's the physics principle, Newton's second law, but we're going to just write it down here. F net equals ma. With vector symbols. We've got 4 forces. I'm going to write them in the same order I've been writing them in. Force applied plus the normal force plus the force of gravity plus kinetic friction force equals the mass times the acceleration. And then these forces are definitely not in a line. We've got some up and down and left and up and to the right forces. So we're going to break them into 2 different dimensions, a horizontal dimension and a vertical dimension. And that reminds me, you probably caught it. I forgot to put axes in my picture. I've got my free body diagram, but let's pick up as positive and to the right as positive. Right there. Okay. So anything that is up is going to be positive in the vertical. Anything that's down is going to be negative in the vertical. Anything that's to the left is going to be negative in the horizontal. Anything to the right is going to be positive in the horizontal. So now we're going to take the force applied. Now this is the one thing that's different. Everything else is going to be pretty much the same as we had last week. The force applied is partially horizontal and partially vertical. It's to the right, and it is up. Just to show you, I'm not going to draw it on there. Just take another piece of paper. The force applied is this way, right? Force applied. That would be, remember when we did like VI was that way? So the force applied is partially in the vertical, like force applied Y, and force applied X, or horizontal. So we can make it H if we want. And this angle is 30 degrees. If you remember, this would be the opposite. So sine of the angle is opposite of hypotenuse. Multiply both sides by hypotenuse to solve for the opposite. The y is going to be hypotenuse sine. The hypotenuse is not a velocity this time, it's a force. Okay? And that force in this problem was 310 newtons. So this side over here is going to be hypotenuse, 310 newtons, sine of our angle, which was 30 degrees. And this side over here is going to be hypotenuse cosine. So hypotenuse was 310 newtons, cosine 30 degrees. I'm not going to show you the work for the cosine, but the adjacent uses the cosine because the cosine uses the adjacent. I'm going to go back here. So force applied, horizontal. That was the adjacent side here. That's the 310 cosine 30. So 310 cosine 30 degrees. And that's to the right, so that's positive. It's being pushed to the right, positive. So you don't have to put the plus there, but you could. On the vertical, it's up. Up is positive vertical, and it was 310 sine 30. Then we're going to go to the normal force. Normal force is, this is the same as we had last week. Normal force is up, not at all in the horizontal. Force of gravity is down. Oh, I did a different order this time. I put force of gravity before the friction force. Whatever, doesn't matter. Force of gravity is down. That's minus. And the force of gravity is equal to mg if you're near the surface of a planet, right? So 65 times 9.80. It's not at all in the horizontal. And then the frictional force is in to the left. So minus mu sub k, I don't know mu sub k, that's my unknown, times n. Not at all in the vertical, equals the mass. Mass was 65. It's not going to go up off the table. It's not going to go down into the table. It's going to slide across the table, so its vertical velocity is always 0. So its vertical acceleration is 0. And over here, 65. And it could be an acceleration here, but they told us it was going to move at a constant speed. So we're assuming it's not turning as well, by the way. But so assuming it's moving at a constant velocity, the acceleration is 0. Now, what you notice this is saying is the up forces, this one and this one, if we were to take this over to the side, this is all 0. The acceleration, the vertical is 0. So if we took this to the other side, you wouldn't need to do this, but you could. 310 sine 30. I'm not expecting you to do this. I would just have you solve it. 65 times 9.8. I'm going to get rid of the 0. The up forces, the normal force, and the part of the force applied that's upward, are equal to the down forces, which is the weight. But what we really want is that normal force. Just be careful when you solve this. You're going to get 65 times 9.8 minus 310 sine 30. Now, this is, remember this guy's helping push upward. So that's helping the normal force. The normal force doesn't have to be so big. So now we're going to solve for that normal force. Sine of 30 is a half, so half of 310 is 155. So, I don't know, 65 times 9.8 is 637. You can just type in your calculator. Minus 310 sine 30. 482. So the normal force is 482 newtons. This problem is 2 sig figs. I'm going to give it to an extra sig fig, 482 newtons. And we'll take that and bring her on over here. And we got 310 cosine 30 minus mu sub k times 482 newtons. And this is newtons too. Equals 0. So just solve for mu sub k. You need to, you can stop it and do this, but this is going to come to the other side as a positive mu sub k times 482. So we're going to divide both sides by 482, so it's 3. I'm not going to make you write this. I'm just showing you what you'll get. You'll get this side, and we'll take this over, divide by the 482, so over 482. So 310 cosine 30, and I'm going to divide that by 482 equals 0.556 something. It's 2 sig figs, so 0.56. This was newtons. The 310 is really newtons. And this is newtons as well, so it's unitless. And there is our coefficient of kinetic friction, how sticky, a measure of how sticky the materials, this refrigerator and this floor, are to each other. So there is the answer to number 1. You can stop this if you want to go back and look at something else. And then we're going to move on to number 2. I'll set up number 2 for you and let you finish it off. A 35 kilogram crate is pulled across a level 4 by 170 Newton force applied an angle of 25 degrees above the horizontal. This time they gave us mu sub k was 0.50. What's the acceleration of the crate? So, normal force up, gravity down. It is being pulled across a level 4, so if I say it's going to the right, friction, kinetic friction, must be to the left. It's moving, so we know it's kinetic friction, sliding. And the force applied is again, in this problem, up and to the right. And I'm going to pick positive directions there, and that angle is actually 25 degrees. I know it's hard to see that. I don't know if I can zoom in here. That says 25 degrees. Knowns, 35 kilograms is the mass. The force applied is 170 newtons. The angle is 25. Mu sub k is 0.50. And then, what is the acceleration of the crate? Okay. We know the crate's not going to go up or down. We're assuming actually we're not pulling hard enough to pull it off the floor. I'll tell you what would happen if later sometime if we pulled it off the floor, what you would get. So let's use Newton's second law. F net equals ma. Force applied plus normal force. I'll put the friction third this time. Plus gravity equals mass times acceleration. They're not on the line. Make two big wide old columns. Horizontal and vertical. Force applied is again right and again up in this problem. So force applied. Yeah, I think you have a problem in your homework where it goes down. In that case, the vertical would be negative. You put a minus here first. But this is the, if we draw a little triangle in there, this, let's see, I don't know if I can get this to focus. Draw a little triangle in there. It's to the right and it's up. The to the right is an adjacent of that, so we're going to use the cosine. So 170 cosine 25 degrees. That's plus 170 cosine 25. Let's drop this down a little closer, a little bigger. And the vertical, it's also up. It's to the force applied was up and to the right. So the right is positive, up is positive. 170 sine 25. And we're done with the force applied. We've got to the right and we've got up. Plus the normal force in the vertical, not at all in the horizontal. Minus friction. Friction to the left in the horizontal, that's minus. Mu sub k they gave us 0.50. We don't know the normal force, so we'll have to figure it out. It is not equal to the weight in either of these problems, because they're not the only forces up and down. Vertical. The friction's not vertical at all. Gravity pulls down. Minus m times g, not at all in the horizontal, equals the mass, which is 35, times a, there's our unknown. We know that it's not going to accelerate vertically, so we can put 0 over here. Now we're going to solve for the normal force. When you get that answer for that normal force, you'll take this over as a plus and this over as a minus, right? Subtract it, get that normal force. Bring it on over here. Plug it in. We'll get 170 cosine 25 minus 0.50 times that normal force equals 35a. And, get the number here. Divide by 35. Get your answer. Check with your group. See if you got the same thing. When you're done with that, you can start on your homework. You're supposed to bring your book. So, the homework is posted, but it's page 141, numbers 1 to 4. But don't try 2 and 3 yet. 2 and 3 are on a ramp. We'll talk about that a later time. So skip them. So for right now, do 1 and 4, okay, tonight, and we'll do 2 and 3 the next night. Okay? So try number 1 and number 4 in the book. But when you see number 4, the force applied is going to be below the horizontal. It's positive in the horizontal, but negative in the vertical. That's going to change your normal force and make it bigger, right? Somebody's shoving it down into the ground. The normal force has to be bigger. The ground has to push up harder to keep it going through the floor. Have a great day.